Moving on to this new section of rational functions. A rational function is basically just a nice way to say a fraction. So it's just a fraction of two polynomial equations, all right? So these ones are monomials right here. This has a monomial bottom. We're going to talk about why that's important. Because there's one term, and this would be a binomial, and we've talked about that. Because there's two terms, and that's important right here. So you just simplify if it's a monomial, but you might have to factor if it's a binomial. So with this one, it's pretty simple. You're just going to simplify the 20 and the 14. So if you take a 2 out of 20, you get 10, and a 2 out of 14, you get 7, so 10 and 7. And then you would just subtract, so you take 2 out of here, which is 4. So that's all that is. Okay. Now, number 2, you notice that there's binomials, so this is where you have to factor. And the first way you should always look at factoring is there a greatest common factor? So on top, you have 6k and you have 36. Well, 6 and 36 have a 6 in common, leaving you with k minus 6. Now, you can only cancel if factored. Only can cancel if factored. Got it? So these are factored, so you can cancel this out, so your final answer is just 6. So it's pretty simple. Okay. There's a lot of factoring going on, so that's why we kind of covered it earlier in the year, so make sure you pay attention to that. Okay, this is a binomial, and we're going to ask ourselves, can we take any greatest common factor out of it? And you can't. And this is a trinomial. If there's a trinomial, you start with the factor 2, and you say, is there a greatest common factor? Well, there's not. So then you just go, okay, how am I going to factor it? Well, typically if there's 3 terms, that's where it's called a trinomial. Oops. And you need to find the factors of this 48 that give you 2. The one on the top, the y plus 8, is going to stay because there's no factors for it. So when we did factor, and I told you if this is negative, the sign in front will tell you what the highest power is. And one would have to be negative and one would have to be positive because a negative times a positive is a negative. It's the only way you can get it. So then I'm going to go ahead and write the factors of 48. So 48 and 1 is the first factor. You have 2 and 24. 48 divided by 3 is 16. The whole thing we're trying to get is to 2. 48 divided by 4 is 12. Not going to get you to 2. 48 divided by 5 is not a thing. 48 divided by 6 is. And that is your answer. Because the difference between 6 and 8 is 2. Now, I usually say, what are the factors that multiply to here that add up to here? Well, this is negative. You can actually ask what's the difference. And the difference is 2. So 8 is positive, 6 is negative. And if you notice you have the same thing, whenever you simplify, if everything goes away, there's a 1 still on top. So be careful. Okay, it's kind of like if you have 2 fourths. When you simplify this and divide by 2, you get 1. You divide that by 2, you get 2. There, 1 has to stay there. Okay, so moving on to number 4. I'm probably going to make some side work because there's some factoring that needs to go on here. I'm going to split this up. Okay, so right here you're going to have to ask yourself, is there a greatest common factor? Well, there is. And the reason we're asking that is because it's not a monomial, so we have to factor it. So the greatest common factor is 2. So you're left with r squared minus r minus 20. And on the bottom, you ask yourself, is there a greatest common factor? And there is, and it's 8, which leaves you with r plus 4. Now, the 2 and 8 can simplify, so that gives you 1, and this gets you 4. But this can simplify, that can factor, and we did the same type of factor in here. So we're going to find the factors of 20 that give you 1. So I'm just going to write it over here. Factors are 20 are 1 and 20, 2 and 10, and 4 and 5. And 4 and 5 is the only thing that will get you 1. Since this last sign's negative, the sign in front tells you what the bigger term is. So 5. So it's r minus 5 and r plus 4. So you're left with 1 is there, but I'm not going to write it. The factored version of this is r minus 5 and r plus 4. And on the bottom you have 4 and r plus 4. And the r plus 4's cancel, leaving you with this as your final answer. Okay. So I want to do 7 and 6 in this video, and then I'm going to split it up and do the other page as another video, just to let you know. So this right here is called the difference of perfect squares, and hopefully you remember that. And there's three rules with it, and that three rules is 1, is there two terms, 2, is it subtracting, and 3, can you get a perfect square out of it? And that's the case. So the square root of p squared is p, the square root of 49 is 7. So you're left with p minus 7 and p plus 7. And then you have the 7 minus p. Well, it doesn't look like it can cancel with something, but it actually can. So that's what kind of this rule right here is saying. So just to go over here and reference it, if I took a negative out of this, if I factor out a negative, it'd leave me with negative b plus a. And just to check, a negative times a negative is positive, and a negative times a positive is a negative. So this is the same thing. What you can do then, and I'm going to have to do this, is you can actually rewrite this bottom, and you can put a minus b. A is positive, b is negative, and it works. Now these are the exact same thing, but the thing when you cancel is that gives you 1, and this gets you negative 1 on the bottom. And 1 divided by negative 1 is negative 1. So this is saying it would equal negative 1. So the question is, what's similar? Well, this is similar. 7 is negative. 7's positive, just like that. The variable here is positive, but down here it's negative. So these would cancel out, leaving you with a negative 1. So the final answer is negative p plus 7 or negative p minus 7. So it can go either way. All right, last example for this page. Always ask yourself, it's the greatest common factor. So on the top, they have a 3 in common, but they also have an a in common. So that leaves you with 4a squared minus 1. And the reason the 1's right there is because you took 3a divided by 3a, and 3a divided by 3a is 1. Okay. On the bottom, they have a 6 in common, because 12 and 6, the 6 would be in common, and they both have the highest power of a squared at most. So you would divide this by 6a squared, which gets you 2a, and then 6a squared divided by 6a is 1. Now we're not done here, okay? This can factor farther because it's a difference of perfect squares. Okay, so the factor, or square root of 4 is 2, and the square root of a squared is a, and the square root of 1 is 1. So if you factor this, you get 2a minus 1 and 2a plus 1. So this turns out being, this right here is 2a minus 1 and 2a plus 1. You actually can simplify this right here. If you take 3 and 6, that's 1/2. And a squared, this would go to a, and this would be gone. So nothing on top. We have 2a and 2a plus 1, and you should notice that these cancel, leaving you with this is the answer. Now you cannot cancel these out. So my example would be if you have a 1 minus 3 over 1, that'd be negative 2. But if you cancel these out, you get negative 3. So you can't do it here. That's no go. Don't cancel that out. All right? That's the first video. I'll see you in the next video. You should see a link in the left-hand corner.